Hello everyone. This time I'd like to talk to you about the basis for a state machine. Basically what we are going to be doing is expanding on a previous lesson I've had on the task. If you remember it, it's this block here, currently in block 40 in SS32. But I've added a little extra content to the task block. This includes the basis for a state machine. Now, what is a state machine? Well, if you think about it, we have a numbered state and the machine goes from state to state and may flow into a previous state that is known or into a next state that is yet to be executed. However, when we do this in hardware, as always, things are linear, so states are 0, 1, 2, 3, 4, and these are linear in memory. So what can we do with that? Well, if we somehow leverage the case statement, for example, we have a case, something like 1 case off, 2 case off, then you can see that this is basically a state machine. Now, if instead of off, which if you look it up, it's just a return, then, and then drop, we convert that into a yield, like so, and then drop. So we are replacing the return. Then this allows us to yield into another task. So this task could have a state machine running in it, and the next task would have something else, maybe another state machine. So I've implemented these 4 words. I have first the plus case, which just makes it so that you don't have to do 1, 2, 3, 4 and so on for cases. And then these two, TS and TS store. So the TS word just gets the current state machine for the task, while the TS store stores the state machine state for this current task. And this one is pretty handy, TS plus and then question mark, which will just increase the task in case it's just a 0. Now for an example, let me show you in the next block. Here I have 3 tasks named by these 3 red words, t.set, t.sta and t.this. The t.set will just set the canvas, so to speak, to draw some text. This is just some boilerplate OpenGL code. Same with the t.this, which will just check if we press escape with this O by word, and will display and will just poll keys just so we can have a responsive canvas. Now the main action of this block is this t.sta. As you can see, I'm using the plus case word in green because I'm just compiling the case and increasing 1. So all I have to do is put a 0, an immediate 0 that is. Then I'll do all the plus cases, and finally I'll just drop that 0, or in this case it will be a 3 because it will be increased about 3 times. Now the next step, I'll just begin the case statement using the TS, which will just fetch the current state machine ID for the task, and then I'm going just to print some words, wait 1 second, that is 1000 milliseconds, and then set the timer to 0 and increase my task. So if I press F5 and run it, you can see it's running and it's waiting 1 second and then switching tasks. So it will just go from task to task, and then finally at the end it will just set the current state machine to 0, and then this will go ahead and do it again. Now for a more involved case, I don't know if you have seen the video I posted sometime earlier with a cutscene that I did using this same exact method. I think this is a good way, although it's a little bit more on the complex side. Maybe for the future it should be easier to just have a domain language for cutscenes, but this is the way I found it to do in this case. So let me just load a cutscene just for kicks. I think this one is a cutscene. So as you can see, I loaded and the camera starts moving, and here you're going to see in a second displays text and it waits for input. Now how do I do that? You just get out of the cutscene and you can see that the t.cut task is just a huge state machine using the plus case word. So for example, let me see if I can display the status somewhere here in the t.d task. t.d, let me find it. Oh, it's up there. So if I go and display the stats for this cutscene, you can see that it displays the current state. Let me show you. I think it's this. Oh, you can see here it changed to 1. So I am now in state number 1 after the transfer of the, or rather the move of the camera. Now if I press a key, you can see now I'm in state number 2. And then I press again and I'm going into a different state again. And it will pan and move the camera, and when it's done it will switch states. Now if I press escape and get out of that, you can see that the task will wait until the lerping is around 0 or fairly near, and this is what I'm doing using this ts plus and then question mark word. It will wait until it's 0, meaning it's finished, and then it will switch tasks. And you can do this in other tasks. For example, here in this one I have a different scene and I have words again, and you can see it has another camera pan. So overall I'd say this is a pretty useful technique for games, especially the more involved games such as an RPG, and I think it's promising, but it could be better. So I'd like you to stay tuned in the future for the next steps that we are going to be taking. I need to do a fairly good rewrite of the SS32 since I'm running out of space for the compiled code. It's just something on the background. It's because of the transition to OpenGL, but in the future things should work properly. So with that said, I'll see you in the next video. So take care.